curriculum materials, part of them I have funded while I was at NSF, they all have very good ideas on, and you can always tinker with them. If you don't like those and you like the screen, there are CDs available and DVDs available from different projects which are aware of the science standards and give you new ideas about what you can do. And what I do mostly are things that I have found in this, and there's a whole series of these cookbooks. And I call them mini research projects because you can extract data from them. And for us, the scientific method is play with it, muddle around with it, get some numbers, and then we'll talk about what we have. I don't have them following the sterile scientific method of hypothesizing first. I've never hypothesized first. I've muddled around, done the science, and that's my fundamental philosophy. I want to have the students spend the maximum amount of time doing science, because I believe only by doing science can you learn it. You learn the processes of science. You learn the thinking patterns of science. And if you do enough of that, you become acculturated to science. And that is an enormous step, to become acculturated to science and see it as part of your everyday life. And you start seeing science in the little things you do and when you visit places, and that's nice. At that stage, I think we have succeeded in teaching students, teachers, and myself science, because I keep learning science too that way. I'm actively doing writing work, and if that happens, then I take, again, I'm doing mineralogy right now, and if I have an article that I've just done, I take a copy of it, and I'm willing to leave it in the school. Did I get the wrong one? One of the problems of being a little older. You see, they can see some of the beautiful stuff that you can do if you understand minerals. This is not a professional journal. It is what I call a trade journal. It is edited, but it is not edited by geologists. It's edited by people who are normal, everyday people who want to be sure the English is right and stuff like that. But the students appreciate seeing what I'm doing. And that's one of these overall science standards that everybody hopes students will become acculturated to science, experience doing science. Enough said. I've probably gone beyond my time, John.
Thank you, Wade. Ed, you want to give us a little insight about what's coming down the line in the world of science standards?
Sure. I gave you all this little packet. If you are intensely motivated, you can pop online to the National Academy's website and download the full framework.
What is this?
This is the new K-12 science framework. We had a national set of science standards, and we had the American Association for Advancing Science 2061 report, which was essentially giving us a broad guideline for what should science be like in the classroom. States then took a look at those two documents and wrote their own sets of standards. Over the last 3 years, National Science Teacher Association, a variety of other groups, together with the National Academies, have created this new K-12 set of science frameworks. From these frameworks, and I put down a little bit of a timeline there at the very bottom, from these frameworks now, a group called Achieve.org, through funding from the Carnegie Foundation, is going to be creating a new set of next generation science standards. You'll notice that I did not say national standards because the day you say national standards is all the states say. That's violating states' rights. So just like the Common Core standards that have just come out for math and language arts reading, that all but I think Texas and Alaska have adopted. So it's essentially become a national curriculum. But the core math and language arts standards. So too now the next generation science standards will be out there for people to use. D.C., Virginia, and Maryland are 3 of the writing groups, states that have signed on as writing groups. I think that there are so far 26 states that have signed on, which accounts for about 58% of the population in the United States in terms of student size. All the people who are writing, participating in the writing, have also said that they will take a careful look at adopting those next generation standards when they become available. From a timeline point of view, the first draft will become available in April, March or April, for public comment. The second draft will become available, and that'll be the final, probably by the end of 2012. The states then will take a look at them, choose to adopt or not, and then write assessments that will drive them. So by probably the beginning of the 2014-15 school year, they'll be starting to be put in place in places. There are three things to keep in mind. You were talking scientific method. And every teacher who teaches science K-5 lives by hypothesizing, predicting. And what the new framework does is say, really, there are science practices and there are engineering practices. What did I just say? I said science and engineering. So the biggest difference in the K-12 science framework is that we're asking K-12 teachers to now not only teach a lesson where they're using science practices, but they're also integrating engineering. Big difference. Big difference, big change. Makes it a lot more practical, though, and I'll tell you why in just a minute. The second thing is, so there's not going to be a lockstep teaching of scientific method. There will be an understanding that there are practices that every good scientist uses, and there are practices that every good engineer uses, and it's a process. It's not just a method. The second thing is, as you're teaching any piece of content, there are big, and this was part of the 2061 or American Association for the Advancement of Science report, overarching ideas like scale and size. So when you're teaching about cells, something you can just barely see down to the size of the genome, or a gene or a chromosome, understanding and having kids understand that difference in scale is critically important. And understanding that is critically important. Understanding that cycles and patterns, when you're teaching about rocks and geodes, what is the rock cycle? How does it work? What kinds of pressures are you understanding? What kinds of temperatures are you talking about? What kind of time scale are you talking about? Minutes, days, eons. What's the difference between a classroom day versus a geologic time scale? Some teachers feel that the classroom day takes a geologic time scale.
Never ends.
But, it just keeps going and going and going. So understanding and helping kids understand not only the vocabulary, but also what's the big picture that's happening around the vocabulary. So when we're talking about the water cycle, and you're teaching the kids learning how to boil water, you're also encouraging the kids to understand that there's a water cycle, there's a carbon cycle, there's a nitrogen cycle, there's a life cycle. There's a whole bunch of different things. When we say cycle, we understand that there's a beginning, middle, process, end, and it keeps going around and around. And so once I grasp the concept of water cycle from vapor to liquid water to solid water and ice, back into water vapor through sublimation, once I understand that, then when I start talking about the rock cycle, it's kind of like the water cycle, only it takes really long. And, there's really different temperatures involved. Different levels of energy. Then kids start seeing connection. And so that's another big emphasis here. The third thing are disciplinary core ideas. And what the